I mentioned before in a previous video that the area problem occurred about 2,500 years ago, so we're going to look actually about 2,000 years after that. So we're talking about 500 years ago that this idea of what's called the tangent problem arose. Most things in math and science came about because of a problem that needed to be solved. So we're going to take a look at what this tangent problem is. So to keep along with the theme from before, I'm going to stick with y is equal to x squared. Again, we're just looking at something that's parabolic like this, and specifically we're going to choose a point and then we're going to draw in what's called a tangent line. Alright, so different programs, same graph. We've got the parabola here in red, y is equal to x squared, and then at this point location here we have what's drawn in as a tangent line, and remember a tangent line only hits a curve at one spot. So the problem was, how do we find the slope of something like this? So up until this point we've always had the slope formula to help us, but in this point right here I've got one point to work with the slope formula. That wasn't any good, so here was the idea. If you take a second point and then draw it doesn't really make a difference what side. This is called the point of tangency, and then what you can do is create what's called a secant. I'm going to kind of sloppily draw this in. And if you see the line in green that I just drew, this secant, it's not a bad approximation of its slope, but what the good thing is I would have 2 points, and if I have 2 points I would be able to use the slope formula over here. But you can see it's not a perfect estimate. You can see that the blue line is a little bit less deep and there's a little bit of a gap between them. I'm going to try to recreate what I just showed you in more of a computer model so it's a little easier to see. So what I have is I've got 1 point here and 1 point here to represent the point of tangency, and then another point on the curve. And then just so we can see this a little bit better, we're going to try to focus on this part of it. So what I'm going to do is create basically just a straight line that would intersect these 2 points, which is going to create that secant line that I'm looking for. So what you're looking at here again is the blue line is considered the tangent line, and this purple line right here is considered the secant line. So what I'd like to do is take this point and then I'm going to move it closer to the point of tangency and watch what happens. A little bit better, a little bit better, a little bit better. This secant line is getting closer to the tangent line. A little bit better, a little bit better, a little bit better. Still zoomed in on the tangent point right here. A little bit closer. Again, blue line tangent, purple line secant. See if I can move this a little bit closer. As you can tell, getting closer and closer and closer. I get about to here and it's almost the same thing. You almost can't perceive a difference between the two. So in summary, what we're looking for is, again, the tangent problem is how do you find the slope of a tangent? I can't use the slope formula, so I use 2 points, which creates a secant, and I move that secant point infinitely close. And this tangent problem, and with the area problem, gave rise to the 2 branches of calculus.